Hello Aslam class, welcome to your maths lesson today. It is the 1st of February, the second month of the year, 2021. Just a quick recap of what we've been doing before we do our arithmetic test questions. Last week we were looking at fractions, and we started to look at fractions, and we started to look at things that were called, and this is what a fraction looks like, okay? We were saying that this is the numerator, and we looked at this, and this was called the denominator. Okay, the numerator tells us how many parts we're looking at of a whole. This one here tells us how many parts make up that whole. We then went on to look at unit and non-unit fractions. That one I've just rubbed off was a unit fraction because the numerator was 1. Any fraction where the numerator is greater than 1 we call a non-unit fraction. We then looked at counting up and down in tenths as well, which is pretty straightforward. 1/10 plus another tenth is 2/10. So you literally just count adding the numerators. It was very important that when you are counting up in tenths, the denominator stays the same. You do not add up the denominator, it's only the numerator that you're doing. We then look at just as fractions to understand them. This could be, this is one whole, and this one whole can represent any amount of number. Okay, but we're going to keep it as one whole. This one whole can be split into, let's say, 2 halves, couldn't it? Okay, it's still, these 2 halves make up one whole. So for example, if this whole number, if we gave this whole number, let's say it was 10, okay, these two need to add up to make to 10 because 2 halves make one whole. So which 2 numbers added together give you 10 that are of an equal amount? 5. Okay, so half of 10 is 5, yeah? And you could then split that up into quarters as well, but we're not going to do that at the moment. But that leads us nicely into what we're doing this week, because we are going to be looking at equivalent fractions. And equivalent fractions, well, we'll find out as the week goes on, shall we? But first of all, we need to make sure we do our arithmetic paper, our arithmetic questions for today. So here they are. If I just make it a bit bigger so you can see. Okay, here are your questions for the arithmetic today. If you pause the video, you can then take a few minutes to answer these questions. Okay, welcome back. Hopefully you've done all right on them questions. Let's have a go through and see the answers, shall we? So the first question was 8 times 8, and that is 64. The next question was 132. What's half of 320? The answer is 160. In our the Roman numeral that is displayed there was 268, and then question 4 was 36. Question 5 is 49. Question 6, the answer was 50. Question 7, the answer is 2. It's a tenth of 20 is 2. You just divided by 10. And we added these values together, we get 2,867. For question 9, it was 6,205. And then for the last question, 24 divided by 8 is equal to 3. Okay, so well done for answering the questions correctly. Don't worry if you didn't get them all correct, but good job if you did. Right, it's starting to rain out here. Luckily, I'm underneath a shelter. So we are going to crack on with our lessons. So as I mentioned at the beginning of the video, today's lesson is about recognizing equivalent fractions. So the first thing that I would like you to do, just as a recap of what we did last week, just have a look at these shapes. I know the quality isn't the best, but you should be able to pick out what fraction of the shapes are shaded. So what you need to do, give yourself a minute or two and just quickly go through them questions. And remember, the denominator is a fraction of how many parts there are, and the numerator is what we're looking for, so what parts are shaded. So pause the video and give that a go. Okay, good. So you don't have to draw any of this out. You just need to write down what the fractions are. So in this circle here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. How many are covered in? 5. So our fractions should be 5 over 10. Okay, well done if you got that one right. Our next one here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's out of 10, but only 4 are coloured in. So that's our fraction of 4 over 10. For our next question here, we've got 1, 2, 3, 4, 5, and then another 5 round there. So that was also out of 10, but this time only 3 are coloured in, so we should have 3 over 10. Over here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again, and only 2 of them are coloured in, so that's 2 out of 10. And then the last one here, we've got 10 again, but this time only 1's coloured in, so we've got 1 out of 10. So all of your denominators should be out of 10. You just need to change the numerator for the ones that are shaded. Okay, I want you to take a little moment to think what equivalent means. What does it sound like? A word that you may have heard before. Okay, now you've had a little bit of time to think about it. Let's find out what equivalent actually means. So the term equivalent actually means equal in value. So what I would like you to do, take 1 minute and just to think about what things can be equal in value. Think about it. What have you already done in maths this year that you can actually say, oh, that is equal to that? Yeah. So equal amounts. I'll give you a couple of seconds, a minute or so to think about that. So pause the video and then come back. Okay, I'm going to make myself a little bit bigger because I did leave some space on the screen for me to write on, but I thought it might be better if I put them up onto the whiteboard for you. So things that we know that are equal. Okay, I know that 100 pennies is equal to £1. Yeah, that's equivalent, isn't it? 100 pennies is equivalent to £1. I also know that 3 times 8, okay, is equivalent to 6 times 4. Because 3 times 8 is 24 and 6 times 4 is 24. So it's the same amount, yeah? So this amount is the same as this amount. They are equivalent, all right? Let's think of some other equivalences that we may have. We've got 1 kilometer is equivalent to 1,000 meters. We've done that in maths this year, haven't we? Yeah. So you've probably got more things that are equivalent. These are just a few examples. When it comes to fractions, we can also have fractions that represent the same amount. And these fractions that represent the same amount are called equivalent fractions. Now, equivalent fractions may have different denominators. They can have different numerators, just as we saw in this example, in these examples here. You can have different values, but they represent the same amounts in total. So well done if you've got some examples down there. Now, normally in this lesson, we would be at school, we'd be using these Cuisenaire rods, okay? These rods are different sized rods that have been cut up into different fractions of amounts to help us understand equivalent fractions. However, today we're going to have to make do with pictures. You're going to have to make do with me using it. If you're in school, you're able to use some of the resources at school, so that'd be really good. So make sure you get using them. If you are at home watching this video, maybe you can find some Lego bricks of different sizes, or best yet, on your team's files page, I have put a fraction wall chart up, which you could then sort of download, and if you've got a printer, you can maybe print that out. If not, it's there. Okay, so we're not going to be able to teach it the way we want to, but remotely we're going to do the best we can. So this is called a fraction wall, and you can see on this fraction wall, we've got 1 whole, 2 halves, 3/3, 4 quarters, 5/5, 6/6. What do you notice? I want you to pause the video quickly here. What do you notice about the denominator of these fractions and how many of them there are to make up 1 whole? So for example, let's take 3. The denominator is 3 for 1/3. There are 3 of them that make up 1 whole. So pause the video and just have a look at this, just to help you with equivalence. Well, the rain is really coming down at the moment. Right, on the board behind me, I've set up my own fraction wall that replicates this one here. Okay, and I've got my whole at the top, my halves, my things. What did you notice about the pattern that you see here? Hopefully you should have seen that the denominator represents how many parts. It's just another clearer way of doing it. And you can see where these fractions may line up, where we can get equivalents, where fractions are the same amounts. So let's have a look here, shall we? Here is a fraction, okay? It is half of a whole. So let's take my half of a whole out of the top here, okay? So I'm just gonna make my screen a bit bigger so you can see. So this is my whole, okay? This fraction is half of a whole, okay? My denominator is 2, so I'm going to the fraction that has been split into 2 parts, here and here, okay? So there it is. There's my half, and I'm going to put it down there. All right, so you can see that, yeah? Now, how many quarters are making up this half? Now I need to go to quarters. Now let's have a look. It's got a 4 underneath in the denominator part. So I'm going to go to where I can see 4 separate parts on my wall chart. And it's here, 1, 2, 3, 4. Now, how many of these are going to make up 1/2? Let's find out, shall we? We go put 1 there, and we put the other one there. How many quarters have I used to make half? I've used 2, okay? I have used 2 quarters to make up 1/2. So if you see on this screen now, we can say that 1/2 is equivalent to 2 quarters, because it's the same value, isn't it? Look, it's the same value. We've got 1/2 of a whole, and that half of a whole can be made up of 2 quarters, okay? And if we have a look, if we put it back into our chart here, okay, we can see that 2 halves, or 2 quarters, sorry, make up that 1/2, okay? And you can see that they're the same size. In your wall chart, you should be able to see that as well, okay? So 1/2 is equal to 2 quarters. They are called equivalent fractions because they represent the same amount. So on your wall chart now, give yourself a few minutes just to familiarize you with yourself with it. You don't have to write anything down, but just try to see how many equivalent fractions you can find, okay? So I'll give you a couple of minutes, pause the video, and then you can rejoin. All right, guys, hopefully you were able to find quite a few equivalent fractions on your wall chart, on your fraction wall, okay? You can see here that 1/2, okay? All of these fractions here below 1/2 are equivalent to 1/2 when they're represented together, okay? So for example, 2 halves make a whole, 3/3 make a whole, 4/4 make a whole, 5/5 make a whole. So when they all make a whole, when we use them all together. But now let's take it back a bit. Let's have a look at our halves, okay? So here's our half, right? Let's go down the middle and where the lines match up. So here, and here, and here, and here all the way down to the bottom, we can say these equivalents to halves, can't we? Now, the third doesn't match up, but we can say, look, 2 quarters make up 1/2. We can have 1, 2, 3, 4, 5, 6. We can have, let's use this one. I'm missing my 6, don't worry. We can say that 4/8 is also a half. We've got 3 6s here. That could be a half. We've got 5 10s that make up that half. And we've got 6 12s that also make up that half. So lots of equivalent fractions that we can see there. We can also see, if we put them back in, let's take our fifths. We've got 2/5 here. We can see that 2/5 can actually be made up of 4/10. Exactly the same size, yeah? Exactly the same size. So hopefully you were able to find quite a few equivalent fractions. Now for today's independent tasks, you need to be doing the following, please. So for task number 1, everyone should give this a go. You should all be able to do it. Make sure you've got resources, if you have them at hand, to help you out. All you need to do is write down the equivalent of fraction for each of these pictures. The task number 2 is simply you need to draw the pictures out, and then you either draw the arrows or you can just label where which each bar model represents its equivalent fraction. Okay, so you won't, I'll talk about this one when I go through the answers, but you're looking to find the equivalent fraction to the one that you on the right hand side. And in this picture here, this is a bar model that represents 3/4, which bar models can be used to show a fraction that is equivalent to 3/4, shading the bar models that work for that statement. So this is task 1. Everyone should be doing this. If you want to push yourself, do challenge 2. But if you want an extra challenge to really push yourselves, go on to challenge 3. Make sure you put all your work up onto Tapestry. I'm now going to go through the answers with you. So pause the video and then unpause when you're finished. Okay, so for this question here, well, the rain is really thundering down at the minute. For this question here, we have 1/2, okay? So let's take my half, okay, and I've got 4/8 underneath, okay? They are equivalent because they are the same amount, and you can see that there. So we've got 4/8 make up 1/2. Very good. Now let's have a look at this one here. We've got 1/4. So let's put our half back in. Let's move them there. Here is our quarter. Okay. How many do we have underneath that quarter to make it equivalent, to make it the same? We've got 2/8. Okay. So we've got 8 as our denominator this time. And you can do that also by counting how many parts we have up at the bottom here. And then for this last one, okay, we've got 3/4, 1, 2, 3. And how many do we have here? 1, 2, 3, 4, 5, 6. We've got 6 shaded and 8 parts in total. So 3/4 is also the same as 6/8. Well done if you got all them correct. For your next challenge, you needed to find the equivalents for these bar models. So you could use manipulatives as well here to help you. So for question 1, we've got how many we've got shaded? We've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 in total. Okay, so we're looking at a yellow line here. Then let's have a look over here. What is equivalent to 2/8? So we take our 2/8 and we find out which one's equivalent. Is it a 5th? No, it doesn't quite fit, does it? Is it a 10th? No, we're way off. Okay, is it 1/4? Yes, it is. So the top one goes with 1/4. Our next one, we have 1 shaded in, and we've got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 parts. That is this one here, 1/8. There's no equivalence for that. We then have this one here. We've got 6 parts in total. 3 are shaded. So if we go to our 6, I'm missing my 6s. But if you were to go to your 6, okay, we could put a half on top of that one. And then the last one, 1/3, goes down here into 2 6s. Okay, the final question. This bar model represents 3/4, so that's 3/4. Which bar models represent 3/4 at the bottom to show the equivalence? Okay, so what are you going to do? You're going to get your 3/4 ready like this. Okay, you're then going to let's make that a bit bigger so you can see how I do it. Okay, now let's have a look here. We've got 1, 2, 3, 4, 5, 6. We have 6 numbers there. Can we divide 6 into quarters to begin with? No, we can't. So unfortunately, this bar model, we won't be able to show 3/4. Okay, we can show a half, but we can't show 3/4. This one, we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's take our 8. Okay, here are our 8, the yellow ones. Do they fit and make up our 4 quarters? Yes, they do. Okay, but we only want to know what 3 quarters are. So we take one of the quarters away and we're left with 6/8. So you would shade in 1, 2, 3, 4, 5, 6/8. So that one is correct. And then the bottom one here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 bars. Okay, so now let's get rid of our 8s. Let's put them back up here. Oh, dear me. And then we get our 12s. Can 12s make up 3 quarters? There is a quicker way of doing this, but obviously this way is the best to sort of help you visualize it. Okay, so we can see that our 12s go into quarters exactly. We want to take away 1 quarter. How many 12s are we left with? 2, 4, 6, 8. 2, 4, 6, 8. And then add on 1 is 9. So you should shade in 9 of your boxes and tick that one. Okay then, guys, that is the end of your maths lesson for today. If you do have any questions, please post a message up on Teams, and I'll try to get back to you as soon as I can. Please put your work up on the tapestry. Good luck. We're doing this all week. Take it at a slow pace. Well done for today, guys. Good job.